All right, let's get busy. Here, let's take a look at current events again. Let me see, am I there? Yeah. Okay. Let's see what we're looking at for current events. The not so woke Generation Z. Async await, the worst thing to happen to programming? Uh, I don't know. Let's see. Where's the link? Oh, it's a member-only story. Well, I'm not looking at that then. But let's see. It complains that async await infects all the code that touches it and forces the callers to use async await too. Um, I'm most familiar with it in JavaScript because, of course, JavaScript is the language I know the most. In JavaScript, it just returns a promise, so it doesn't actually do that. Promises behave similarly. Must wrap your code in promises all the way. Yeah, that's sort of true, except, of course, you can, like, if you need a callback API, you can just have it call the callback function when the promise returns, or when the promise goes then, when it resolves, I guess is what I'm saying. So, I don't know. Um, Go channels, if you want to asynchronously interact with a channel that is without blocking the main thread, you have to do it in a Go block, and the caller has to do the same, and so on. Um, this is true, of course, but I actually haven't done this in Go. I haven't practiced that much with Go, to be honest. Um, yeah. So these constructs are alternatives to the good old callbacks, and the callback is cool. The callback is cool. The event listener is another possibility that I really like. Does Delegate talk about the event listener? Um, Cascade infection effect is due to the inherent nature of things happening asynchronously, which contradicts the synchronous program flow inside a thread. So when the async event terminates, the program has to jump to a handler in order to process the results. Yeah, so I think that using an event handler is in some ways maybe the most straightforward. Um, but all of these others are good too, in my opinion. All right, so anyway, let's go back to exercism. That's enough looking here. Exorcism it is, baby. Okay, so I was going to... Let's go back here. So I was going to look at... Oh, I didn't finish this one yet. Okay. I did it in... I did it in Python? Interesting. Okay, so I still have to do it in WASM and Swift. Okay, okay, I'd forgotten. It was like last week, so I guess I'd forgotten. All right. So let's let's see. So what I was going to do here, let's take a look. Sysm, let's look at, I did it in Python, right? Just to help myself grok it a little bit better. So let's look at our difference of squares file. There's not much here, right? So we know we can square the sum by using this formula, right? So let's hop in here. So if we're in here and we say square of sum, right, equals lambda n, and it will be n times n plus 1 divide 2 square, right? So square of sum 100 gives us 2550, 25500. Was that given as an example in here? Let's take a look. Difference of squares. Let's look at the Python. Okay, so they give the example of 10, right? 30, 25. So I mean, this is good, right? Let me crack it open in here as well. Okay, so square of sum equals x, and we said x, where'd it go? Times x plus 1 over 2. Is that it? Square of some 10. So this is in our JavaScript. Okay, so far so good, I guess. So then let's see. Okay, so then if we are doing sum of the squares, then we have to add them all up, right? So let's look at that real quick. Sum of squares, slow, equals x, and then we'll go, I guess, what did we do in Python? I like it in Python where we just do this sum in range. This range is nice. We don't really have that range syntax in JavaScript. We can go new array x fill and then reduce and then act I. And then what are we doing? We are squaring each one and then summing them all together. So we'll go ac plus I square like this. So if we do 10, oh, I got NaN, so I didn't do it right. Oh, I need this here. Is that better? 285, it's not correct. So we need to do +1 right. Or actually, let's do just +1. Okay, so that's the 385 that we kind of expect, I guess. So then if we do sum of squares equals lambda n sum n square, let's say x square for x in range n plus 1, sum of squares 10. Okay, and 100. Okay, 338, 350. Okay, so we get the same thing here. So now I was gonna try and guess, like, what is the formula? I can always look it up. Let's time box it. I will spend up to 21 minutes. At 6:30, if I haven't figured something out, I will look online to try to discover the formula. But I just want to mess around with it a little bit. Okay, so if we were to go... Okay, so we know the formula that we used for square of sum. So that's that. So that's a much higher number, right? And then if we kind of reduce this, or just sort of maybe rearrange it a little, square of sum 2, x, like let's distribute that x. So we'll say x square plus x over 2, and then square that. No, I don't think that's relevant at all. Okay, so sum of squares. Sum of squares. So what does this do if I pass in minus numbers? Oh my gosh. Is that what it's supposed to do? Is that what it does in Python? Okay, so that does make sense. I guess, maybe? It gives the same answer either way. So we sum all the numbers. Sum range minus 100, and then square that. So it's not the same answer. I don't think it's meant to handle negative numbers, so actually, what does it say in the exercism? It says natural numbers, so it's not meant to handle negative. So negative, that's beside the point, right? Okay. All right. So, do I have an idea of a formula? So here they don't use the term formula, they say an efficient solution. And yeah, I don't really know any first principles. I don't know if I ever did. I think when I took Calculus 2, I was supposed to learn some of the principles that are relevant here, but I didn't really learn them very well. So, and that's been a long time ago. So sum of squares is the one that I want to find a formula for, right? Okay, so let's just look at some of them. Sum of squares x for x in range 10. So we'll have a 0, a 1, a 5, 14, 30, 55. Does this seem familiar? Does something about this seem familiar? I'm not sure. Maybe. So each time we do see that, of course, we add the number squares. So we start with 0, we add 1 square to that, we add 2 square to that, get the 5, add the 3 square to that. Okay, wait a minute. I do know the first principles here. It's a recurrence relation thing, right? I at least remember that term, but do I remember how to make a formula out of it? No. So then, yeah, so then we added 3 square, got 14. We added 4 square, got 30. Okay, we added 5 square, got 55, and so on. Okay. Yeah, so that's fine. Now, one thing we could consider is, rather than a formula, one thing that could be efficient might be to memoize. Should we think about memoizing? Because that could improve efficiency. Let me make a note of that somewhere. Maybe we want to consider memoizing. Where do I want to make a note of that? Let's just go. Maybe memoize. Okay. Maybe memoize, but yeah, I do feel like there's probably a formula that would make sense. Maybe, I'm not sure. Memoizing could really improve the efficiency, for sure. You know, I said I was gonna look or mess around with this, but actually I do want to get stuff done too, so I'm gonna cut the messing around short. Okay, so let's look recurrence, relation, adding each number square. Something like that. Okay. Wait a minute. Is this formula going to help? Okay, so if you have the previous square, then you add n minus 1 and add n. Maybe this will help. I should start using like some sort of a drawing program or something. Should I put that in my notes? I don't think I'm going to, but yeah, so if we use this formula, we still need to have the previous square number. So that still makes me think memoizing. Oh, you know what? This might give the answer. Solving. This is going to be too hard for me. Let's take a look. Okay, linear recurrence with constant coefficients. First order, let's see. I might be in the wrong place. I don't know, let's see. So the nth term is equal to some combination of the previous terms. Okay, well that's good then. So far so good. Is it this? This is gonna be hard for me to understand. I should probably read the whole thing. Okay. In mathematics, including combinatorics, linear algebra, and dynamical systems, a linear recurrence with constant coefficients, also known as a linear recurrence relation or linear difference equation, sets equal to 0 a polynomial that is linear in the various iterates of a variable. Okay. That is, in the values of the elements of a sequence. The polynomial's linearity means that each of its terms has degree 0 or 1. Okay. So that's not what we're looking at because we square something, right? What was that formula that it showed again? Yeah, they squared this. So that doesn't quite sound exactly right. Or am I crazy? I feel crazy right now for sure. All right. Um Wait. Yeah, this one. Okay, merely adds the two previous terms. Well, that's not it. Unless, wait a minute. No, that's not it. Not it, not it, not it at all. Okay. Okay, let's go back here. So, research is allowed, indeed encouraged. Okay, let's try researching some different direction. TC Arcus followed. Thanks for the follow, TC Arcus. You rock. Okay, so We are doing sum of squares. Sum of squares formula 0 to n. Something like that. Oh, does where's Wolfram? Wolfram will tell me. Sum of squares from 0 to n. Oh my gosh. Yep. Didn't I say Wolfram will tell me? And it did, in like no time. In no time. Okay, let's try this. This is the formula. 1/6 n. Oh my gosh. Amazing. Amazing. Um, yeah, let's see. This is, oh. I am so happy. Like, as soon as, I don't know what it was, as soon as I put that in, I thought, wait a minute, Wolfram will just tell me, won't it? And it looks like it did, so we're gonna try it out. Okay, so we're gonna do sum of squares fast equals lambda n, and this time we'll use the formula. So we'll take 1/6 times n, all right? And then we'll times by n plus 1, n plus 1, and then we will times by 2 times n plus 1. Does that seem right? Right? That's what Wolfram says. Okay, sum of squares fast. Let's do the same thing as before. X for x in range 10. Interesting. So these are close, but not quite right. I have floating point errors here. That's pretty messed up. Okay, so let's we know the final answer should be an integer, right? So let's use integer division by 6 at the end instead. So we'll get rid of this. Put this all in parentheses. And integer divide 6. There, is that better? Much better. Much better, baby. Oh yeah. All right, so that's our answer. So I'm going to resubmit that with credit to Wolfram Alpha. In fact, I'm just going to copy that link too. Okay. So let's do difference of squares. Okay, so we want the efficient solution this time. And it's going to say n times n plus 1 times n times, or let's say 2 times n plus 1. Whoops, let's put this in here. Integer divide 6. Amazing. And credit to, whoops, Wolfram. Amazing. All right, so let's try it. Sure, let's just submit it. Let's see if it's accepted, baby. Okay. So cool. So if we look, so it's interesting. So it will show these iterations, right? So I have 2. So iteration 1 said square of sum, and I just kind of remembered this from school that you could do this. And then I went sum of squares, and I note not the efficient solution because this is a linear time solution for something we should be able to solve in constant time. But did I know how? No. Not until I looked it up on the amazing Wolfram Alpha. So, that is awesome. So cool. Let's go to the next. T carcass, just a casual cubic polynomial that is always the solution? Yeah, I mean, did I imagine that it would be probably something cubic? I guess, sort of, but did I know what it was? Not without looking it up on Wolfram Alpha, which is awesome. All right. Let's go now and go back. And where is my WASM? Wait, where is it? Let's go back. Okay, we want 48 and 24. And this... Okay, so now I think I already have this locally. I don't know how I'm going to do this. I'm just going to try. WASM slash difference. Okay. It should be easy, right? Because it's just a math formula. Let's try it. So let's go into our watt file. Nope, not the spec, the watt. Okay. Module. Calculate the square of the sum of the first n natural numbers. Okay, so I have 42 in here. That won't do. Let's do... Okay, square of sum. So this is the one... Let me look at it again where I was. Difference of squares in Python. Okay. So let's do number times number plus 1 over 2. Wait a minute. So the number is $max. Do I still need the dollar? I don't know anything about this syntax. Okay, so I'm going to say max. Let's see. Max times max plus 1 and over 2. There's no way. Let's see. WASM syntax operators. Text format. Okay, let's take a look. S expressions. Okay, that's what we've got here. Cool. So yeah, so this is our text format. Stack machines. Types. No. Where should I be looking? Operator? No, shoot. Oh, this is better. Maybe. Let's take a look. Numeric instructions. Okay. Abs. Oh. Add, subtract, multiply, divide. Okay, remainder. I don't think I'm gonna have a power option. So wait a minute. Is this about the text format? Text format. Let's go in here. Okay, conventions, characters, values, numeric instructions. Oh, that doesn't... Oh, that's better. I was like, I'm not going to read that. Oh, no. Okay, so let's see. C... Oh, my gosh. Multiply. Well, all I'm doing is squaring it, so... Let's just multiply it by itself. Oh, can I set this as a variable? Let's see, export difference, call square of sum, put max here, and then put minus, oh man. Okay. Func? I feel like maybe, do I need this? And then subtract, call sum of squares, and then no, this shouldn't be const. What is this? It should just be max, maybe? I don't even know. Max. Yeah, I don't think we do I-32 const. But maybe, I don't know. Okay, so here, I'm gonna put one more. I'm gonna put times. I don't know if that's times, but max times. I'm just gonna put it again. But I don't know. Yeah, okay. So this is numeric instructions, I-32 const. So I think we actually do have to do I-32 add or whatever, probably. Let me see what it said. Oh gosh, let me see what it says when I try running. I don't remember how to try running. So to run, it's in the help. This is the first time I have seen someone writing WASM. This is the first time I've attempted it. Thanks to the amazing exercism. No, yeah, I think it's a wonderful challenge. They're challenging you to use all of these languages. I don't know if you've seen this already, but basically I'm trying to get caught up, but they have you use Python, Clojure, MIPS, JavaScript, Nim, C++, Ruby, R, Common Lisp, Elixir, and so on and so forth. In short, it's kind of a lot. So do I know how to write WASM? I do not. But I'm trying to learn just enough to be able to do this math problem. And then move on. All right. So, how to debug. Okay, so something about the console log. Okay, I'm just going to try running it. Test. So it says module not found. I think I have to npm I first, probably. Yeah, the jest. Okay. Wow. All right. So let's do test again. So now it says error compiling. Okay, unexpected token. Okay, okay. So let's fix all this. We don't do it like this. This is nonsense. All right. So first of all, in here. So we're going to go int add, and then we're going to go max, and then we're going to go 1, I think. We might need the $sign there. So conventions. I think I'm going to try it with the $sign. Token, keyword, white space, comment, shoot. Values, integer, floating point. Identifiers. Okay. Symbolic identifiers that stand in lieu of indices start with $. So I think I need $, regardless. Okay. So I'm going to put $max and then 1. Okay. Okay, okay. So then here it's going to be int mul, and I'm going to put max and that. Okay. And then here, I believe it's going to be int div and that. I want to say it's something like that. And then here, it'll be int mul, and then we'll get rid of that. Okay. So then let's copy this, right? And paste over here, I guess, and then get rid of this. Okay, does that seem any better? Int div. Wait, something's misplaced. So we're multiplying these two together because we're squaring. I think I have an extra. Do I? Okay, so then we need dollar here and here. Okay, so then the instructions that were given were numeric. Oh no, it's not int, it's I32. Is I32 what it's been? Yeah, okay. Okay. Okay, okay. Wait, where did I put all my instructions? This is multiply. This is divide. This is, was this one multiply? And this one was add. I don't know how, I didn't. I'm gonna probably look at the VOD and I'll see what I did wrong. In fact, if I start looking at these VODs more, I will probably improve more. Best viewers on streamboo.com remove the space. You know, informed Newell. Thank you for chatting. I wouldn't. Nah, I'm not gonna BS you. I would have known to remove the space, but I'm not going to. But thanks for the message. All right. So that's more like the way I imagine it might be. And then let me put the dollar here. And then here, I'm gonna put dollar here. Okay, let's see if it compiles now. Or assembles, I guess. I don't know. So let's see. It says unexpected token export, expected N instruction. Export. Interesting. Let's do them one by one. Okay, so I32 div, expected and expression. Oh, interesting, interesting. Unexpected token max, oh my gosh. Okay, do we have an example? I32 div. Here, is this an example? No. Okay, here's an example. I32 const 0. Okay. Here's another example. Func export. Is that like what I have? Let's go back in here. Func export. Okay, so then it has like a name. All right. Then something happened, something else happened, and then this happened. So I was trying to use, I guess, a lot of different parentheses, and that's probably not what was wanted. That was just a wild guess on my part. Okay, so let's see if I can understand anything about this. Pass offset 0 to log, pass length 2 to log. This is pretty different. I think this is pretty different from other things that I've tried. Yep. Understanding WebAssembly text format. I am pretty far from understanding it so far. Okay. So we did something here, something here. Oh my gosh. String length, call. Whatever I tried to do was obviously way, way off. Like, not even close. Wow. All right. So I probably need to start more from the beginning. Okay. I don't want to read everything. I just want to know enough to finish the math problem, but I am gonna have to read something here that'll help me. Okay, integers, floating point. Yeah, that's fine. Instructions. Okay, a sequence of instructions. Okay. Do I... Oh my gosh. I don't need... I don't need SimD for this one, although it might... No, I don't need SimD for this one. Variable instructions concerned with access to local or global variables. Okay, so I should try setting something. Maybe? Oh, this is so weird. This is quite different from other languages that I've tried, or at least it seems that way. I think I'll figure out what is similar to other languages at some point, but not I don't know yet. Okay, so I'm gonna say okay, so param is $max I32. The upper bound, okay. Oh my gosh. Okay, so let's start by saying, what if we just say, okay, I32 add max 1. Okay, so then what happens when we add that? Do we need to local set or something? Okay, hold on. In this article, S expressions, a module is represented as one big S expression. S expressions are a very old and very simple textual format for representing trees. The tree is pretty flat, mostly consisting of lists of instructions. I was trying to nest it like crazy, but I don't think that's the way to go. Um okay. Okay, so we have a function. This is gonna take me a while. Okay. Yeah, we had a type explicitly declared. Sure, okay. Ah, okay. Local get 0 would get the I32 parameter. Local get 1 would get the F32 parameter. Local get 2 would get the F64 local. Okay. So, whoops. So I have a param and a result. Oh, uh, interesting, interesting. So I should set up some more, I should set up some locals probably, I guess. Okay. So I could have a local, maybe that would be, do they show the result in here? Yeah, the result I32. The result, okay, so they get, oh my gosh. So they get it twice. Does that mean it's... Oh my gosh. I think it clicked what is happening a little bit. I'm pretty slow on the uptake. Okay. Okay, okay. So, wait a minute. So if I just say local set 1 and then local get, no. So I want to say, why does it keep going over there? I want to say I32 const 1 because we're going to add a 1. Then I'm going to say local get $max, and then I'm going to say local add. No, not local add. What am I doing? I32 add. Okay, to add those together. Okay, so we have a 1 on this. We got a 1 off the stack, or we put it on the stack rather. We push the 1 to the stack, then we get the $max, put that onto the stack, and then when we call add, we get 2 things from the stack, and then so now we have the 1. So now if I set, does it set whatever is on the stack? Where's local set? Local set. Okay. It only has it 2 places in here? Oh. Why assembly? It's on the list. It's on the exercism list. That's what I'm on. This is the first WASM problem on the list. So the more recent ones we finished, I mean, we finished one in R, we finished one in C, one in Scheme, one in Python, one in awk, one in Perl. So, I mean, there's just a bunch of them. So we're just getting broad exposure. We're broadening our horizons to various things. But man, this one has been a brain melt for me so far. But I think I maybe understood something. But basically, so I think that if I do const 1, that pushes a 1 to the stack. And then if I get the $max param, I guess that pushes the $max, whatever is in there, to the stack also. So then when I do add, I guess it pops the stack twice, which means I'll get the max and I'll get the 1. And then it will do the addition and then push that to the stack. Which means now I want to save a local for max plus 1, I believe. So I think I might need to declare it here, local max plus 1, and say that's an I32. And then I want to say, I think maybe what I need to do is go local set, and then max plus 1. And then I think, I'm guessing that local set will pop something off the stack and set it to my local. But let's see if it says that or explains that somewhere. So let's see, local set is right here. So this is understanding the text format. Let's go to the start. WebAssembly concepts. Do we have something about the locals in here? Maybe not. Let's go to... we're not compiling. We're writing it in the text format, baby. JavaScript. No, we don't need that. Appendix? Local. Oh, there's not anything about local in here. Locals? Okay, so what I'm going to do now is I'm just going to try writing it out And I'm just going to see what it says once I'm done trying to write it out. I'm going to try and compile it again. And I don't know. We'll see what happens. Okay, so I'm imagining that if I do local set, it will set that. Okay, so that takes care of this part. So now I need to multiply max by max plus 1. So I'm going to do local get max, local get max plus 1. So I believe that pushes both those to the stack. And then I do I32 multiply. And then I guess I'll want a local for max times max plus 1, I guess, and that will be I32 as well, I suppose. So then I'll local set dollar max times, what is it, times max plus 1. I forgot the dollar up here, my goodness. Okay, so then I would have that, so that part is good. So now we need to do a division. So again, I'll local get this, local get, oh no, this one's a const, so I'll do I32 const 2, and then I32 divide. So is it going to divide by the thing on the top of the stack? Or do I need to switch these? Let's see what it says about divide. Instructions. I32. Where is it? Text format. Instructions. Numeric. Divide. Okay. I guess I'm just gonna have to try it. I've got divide SX. Okay. Okay, I'm just gonna try it like that. If I have to switch them, I'll switch them after. Does it seem like it would divide by the thing on top? I feel like maybe, but I don't know. Okay, so let's local set, and then this one will be, let's see, once we divide, that's the sum, right? Okay, so I'll just put sum, and local sum, I32, yeah, okay, that's cool. Okay, so now we've got the sum, so then we are gonna get the sum twice because we have to square it. So I'll local get sum twice, and then I32 multiply, and that is the final answer. All right, let's see what it says when I do this. Okay, it says I32 div, unexpected token. Oh, I have a mismatched bracket or something. Okay, so that matches there. Oh, what's mismatched? What did it say again? On 20, unexpected token I32 div expected. Okay, let's look again. I32 const 2. Do I need a parenthesis with that? I'm not sure. I think it showed something like that. Hold on, let me look again. Text format. So they did I30, so they're not using any parentheses there, but I think they did use some parentheses somewhere. Oh, what is this? Global get. Um, data. No, I don't know. I should include more comments. Here, let's comment for what I think I'm doing. Okay, so here, this is the one to add to max. Push max to the stack. Add the last two items on stack. I guess let me say top two. Okay. So then why was it saying that about the parentheses? Let me see, what was the other complaint that we saw? It said 49, unexpected token. Okay, yeah, definitely won't be able to do that. So let's fix that down there. Okay, yeah, can't do this for sure. So I think we are going to call the first one, call square of sum with max as its param, I don't know, and then call sum of squares max. Okay, so the guess is that the result of each of these calls will be pushed to the stack. All right, so then we just call I32 sub, and that should be it. Okay, let's see what it says now. All right, it says call, okay, unexpected token max expected parenthesis. I don't know. So should this have a parenthesis around it? Maybe? I don't know. Okay. Unexpected, oh no, yeah, expected parentheses. Hmm. Expected close parenthesis here. Well, let's just give it what it wants and see. I mean, I don't understand, but let's give it what it wants and see what that does. I don't know. Okay, so now it says, okay, unexpected token, I32 div, expected parenthesis. Okay, so it didn't want that, but maybe at the front? There's no way, that's crazy. Okay, well, it says this, it still says the same thing. Oh, what if I add a second one? There's no way, that's crazy. Expected end of file, okay. Yeah, so I have I32 const 2. Wait a minute, wait a minute. I might have to count what is on the stack. So I think that I believe that I'm pushing something to the stack here and here. I believe I'm popping twice and pushing once. What does this do? Does this pop? Because if this pops, then... Shoot. Okay. Wasm local set... I don't know. Ah. This is more like it. This is under WebAssembly variable instructions. Okay, sets the values of a local variable. Okay, so load the number 2 onto the stack, store the number 2 in the variable $val. So does it just peak or does it pop? I think it sounds like it just peaks. Okay, so let's look. So we create a local variable named var. Okay. We set var to i32 const, oh gosh, what the heck? i32 const 10. Well, there's my problem. I need to show like what goes there. Okay, so let's see. So I tried to set, but I didn't show what I was setting it to. So should I put i32 add here? And then when I set again, should this be i32 mul? And get rid of it here. And then we set one more time. And so then this should be i32 div. I'm very suspicious. Let's see. All right. Local set. Okay, expected and instruction. I thought i30. Oh, wait. It told me this and I completely blew it off. i32 div is supposed to be underscore sx. I don't know why it's supposed to be that. Okay, local set, WebAssembly instruction reference, numeric, division. We have underscore u. What are the other options? Okay, here they are. SU. Okay, just S and U. Okay, S is signed, U is unsigned, right? Is that, did I understand that here? So SX is talking about whether it's signed. Ah, here it is. See, I didn't read it. That's the problem. Some integer instructions come in 2 flavors where a signedness annotation, SX. Okay, so do we want signed or unsigned division? I think unsigned, right? Okay, so let's put unsigned. Okay, let's see what that says. All right, unexpected token max. Okay, so let's look at the call instruction. I'm starting to learn things a little bit, I think. So control flow, right? Call, awesome. And so they called greet. But where's the param go? Is the param supposed to just be on the stack? I think it said something like that. Things are starting to come together a little bit. All right. Yeah, signatures and parameters. Okay. Where do we call? Okay, wait. When a function is called, it starts with an empty stack. Calling the function. Okay. Yes. No. Wait. Okay, so they created it. But now where do we call the function? Calling a function. Oh, are they calling it in JavaScript? Oh my gosh. Okay, I guess that's fine. But I want to call it in WebAssembly. Okay, so they called it here. But getAnswer did not have a param. So what about when it does have a param? I think it might take the param off the stack. Okay, wait. Yes, right here, right here. This one has params. Yes, it has params. And so we put them on the stack. Okay, let's redo that. Okay. Okay, right here. So we are gonna put you know, I used local get max for the param. Is that right? It's under WebAssembly variable instructions. Get local. I think we use it to get a named param. Okay, okay. Let's go down. And so here I'm going to say local get $max. And then here we call square of sum. All right. And then local get max again, because we still need that on the stack for the next one. And then call sum of squares. And then I32 sub. Okay, it says type mismatch. Expected I32. Oh, interesting. Okay, let's take a look. So I tried to do I32 add, but there wasn't enough in the stack. All right. Wait, where was that? That was on 12? Okay. Okay. Oh, interesting. So I thought that this was maybe pushing that to the stack, but apparently not. So let's look at numeric instructions. Const. Declare a constant number. Oh, okay. I32 const 10. Oh. Okay, so then back to the variable instructions. So when we get, loads onto the stack. Well, I do not know. I do not know. Okay. Load onto the stack. Let's see. Memory instructions. I haven't looked at any of these yet. Do we need these? You know, I probably don't. Unless it's something like load. Do we need to load from... Why are we using it here? Maybe I do. I mean, that's why I looked it up. No, I don't think we need to load. I don't think that's it. So we're trying to do local set. Okay, so variable instructions, set local. Here's the syntax. So load the number 2 onto the stack. Cool. Store the number 2 in the variable val. Oh, well, that's what I was trying to do earlier. Hmm. Okay. So I32 add. You know what? The problem earlier must have been just the fact that I had div instead of unsigned div. And I got all confused and went way off track. Where's my sunglasses? Okay. Oh, no, no. Oh, you know, I never figured out why that doesn't work. Okay, well, I'm just gonna do this. Okay, let's test. Oh, pass. Well, that's good. That's good. Okay, so let's enable the other tests. Not that. Okay, so where are they disabled? X test. Okay, so they shouldn't pass because I didn't do the other one. All right. All right, that's fine. So square the sum. Okay, so that one works. So let's do sum the squares of the numbers up to the given number. Amazing. All right, so here we go. So we don't want to do that. So let me look at my formula again. So we're going to go like this, basically. So let's start by getting n plus 1. I'm just going to rename this n. That makes more sense to me. Okay, so we're going to go I32 const 1. Man, I actually really like this now that I'm not completely lost. I was lost for like a long time. All right, so we'll get n and then I32 add. Okay, cool. Local set n plus 1. Okay, so then let's declare that local n plus. Okay, fine with that. So then here, what's our next step? We need 2n plus 1. Next, get 2n plus 1. Okay? So this one will be I32 const 2, because we're going to multiply. Local get n. Actually, I guess let's get 2n first. And then I32 multiply. Local set 2 2n. All right, I guess so. Local 2n. Okay. All right, so next get 2n plus 1. So that's going to be, so we're going to do I32 const 1 as we did before. Local get 2n, I32. Okay, cool. Local set 2n plus, okay. Local, oh, I'm not putting the types. These all need types. 2n plus 1, I32. Okay. I32. I32. Okay. So far, so good. So then, what's next in our formula? So we have n plus 1. We have 2n plus 1. All right. So now let's get, next get product, and that's going to be n plus 1. Okay. So I'm going to do local get $n, local get n plus 1. Okay. And then we're going to do I32 multiply and local set. I'm just going to call this first product, I guess. Something like that. All right. Local first product I32. Okay. So now what's our next step? Next get product n plus 1, 2n plus 1. Okay. So we will local get first product. Interesting. You know, I could do a lot more of this just by working from the stack instead of setting the variables. I'm going to keep working this way, but I might consider refactoring at the end if everything passes. So put a pin in that. Here, let's make a note. Note. After getting it to work, try refactoring using the stack without so many local variables. That might be a good idea just to try. But anyway, so now we want to multiply by 2n plus 1, and then I32 multiply, and then local set second product. But that's actually the final product. Local final product is going to be I32. Okay. So then what's our last step? Last step. Divide by 6. Okay. So we're going to say I32. Oh, no. The division is the second part. So we're going to say local get final product. And then we're going to say I32 const 6. And then we're going to do I32 div u. Amazing. And that's it. Let's see what it says. Okay, 9 passed. Amazing. So let's submit. Not pi. What? Oh, shoot. Oh, it's... All right, let's take a look and see if this gets accepted. I guess it should, right? All right, so that's a simple math problem in WASM text representation. Okay, so now let me try refactoring. So it worked, but now I'm thinking, like, do I really need all these local variable names? I think it's nice to have them, but let's just see what it looks like if I try just using the stack. All right, so So here, I set final product and then I get final product. That shouldn't be necessary, right? We should be able to just totally get rid of that. And here likewise. Just totally get rid of those. So then the ones that aren't like right by each other like that. Okay, what's this one? 2n. So we set 2n. Yeah, we should be able to get rid of both those, I believe. And then what about here? We get the n. So that makes it quite a bit shorter. I mean, not that that's necessarily desirable, but I just want to see. I just want to see how it works. So we're not going to use... so we're still using n. That's our param. I'm still using n plus 1. I might try refactoring a little bit more, but let's just see this part. So we got rid of 2n. Still have 2n plus 1. Got rid of first product. And got rid of final product, right? Okay. Okay, does it still pass? It does. Okay, let's submit again. Interesting. All right, so iteration 2, we got rid of some of the unnecessary local variables. I want to try and get rid of some more. So we have these iterations. All right. Okay, let's look again. Okay, so here we do local set sum, and then we get it twice. Is there another way to do that? Can we, like, pop something from the stack and push it twice? Let's see if there's something here that might tell me. Variable instructions, declare t. Oh. Maybe I should t at some point. Sets the value of a local variable and loads the value onto the stack. Okay, so set the var to 10 and keep 10 on the stack. Okay, well that would save one line. Right here, right? This could just be local t. Let's see if it works. Local t sum and get rid of those. Yeah, that's okay. Okay, so here, set and get together, we can get rid of both those. And then if we're multiplying, we can get rid of both those. Okay. So again, here, what did we get rid of? Did we get rid of max plus 1? Yeah. Did we get rid of this? Yeah. We still have some. Okay, let's see. Okay, so still pass. Okay, what else? The one to add, local get max. So seems like we do need to get the max, of course, that's the param. Yeah, I like that. All right, let's look here. This one's just a little bit of a longer formula, right? But let's see if there's still something we can refactor a little bit. So we get n here, we set n plus 1, which we want later. So maybe that's the way to do it. But here's the thing, if we just have that on the stack, and then if we just sort of pop it at the right time, we might not need the local variable. So, in fact, yeah, so if this is pushed here, Then we push one on top of it. I'm going to count on my fingers, all right? We push one on top of it. We push another on top of it. We pop both and push one, so one is on top of it. We push. We pop both and put one. All right? Then here we pop. Then here we push. And yeah, it should be there. So I think we can actually maybe get rid of it. I mean, I may have miscounted. Oh, wait, what did I do? There it is. Okay. Yeah, get rid of that and get rid of that. I think I messed something up. Let's see. No, it's okay. All right, cool. So can a similar principle apply here for the 2n plus 1? Okay, so we set it here, but if we didn't set it here, then it would be on the stack. Then we would push one thing on top of it, then we multiply them together, so that wouldn't work. I think we still, I guess, need this one. Oh, let's get rid of the n plus 1. We didn't end up using that anymore. Okay, so it looks like I probably do still need this. I'm not sure. So we add these together, so there it is. So then we popped it off the stack. We pushed something on. Wait a minute. Oh, okay, so then this one... Okay, so that won't work. So because at now, whatever was there before. You know, I don't like that refactor because now it's harder to read. It's definitely harder to read than it was before. So I don't love that. I'm going to leave it as it is. All right, that's my final refactor. I'm going to move on. Test one more time. All right, let's take a look. Okay, cool. All right. There's still plenty of time. So honestly, that's the first one I've finished today. I've already been at it an hour and a half. But I'm actually super happy. I think this WASM, it's like it reminds me of, like, I never tried actually writing it in a text representation, but when I learned Java, when I first learned Java, we learned about the JVM bytecode, the virtual machine, and how it pushes things onto a stack or whatever. So it sort of reminds me of something like that. Anyway, let's move on. So which of these? So I'm going to close this. Actually, I think I want that still open. Yeah, I'm going to refer back to that. Okay, let's go back to 48 and 24. And the next one is... Oh, wait a minute. Is my WASM not marked complete? Oh, I have to click mark complete. Okay, hold on. Right here, I didn't click it. Okay, cool. All right, so that one's good. So now let's try Swift. Okay. Have I done a Swift yet? Swift should be easy peasy, right? Nothing like that WASM. All right. I don't know if I did a Swift yet. I did list ops in Swift. I'm not sure I even remember what list ops was. I think it was just a simple, like, data structure exercise. Anyway, so let's go ahead and do this. All right, so hopefully this one won't take long. Let's go into sources slash different slash different. Okay. Write your code for difference of squares exercise here. Okay, so it's supposed to have a method, right? Okay, I'm gonna look up the syntax. Swift, I haven't really worked with Swift, but I feel like I should remember a little bit. All right, Swift method declaration. All right, let's take a look. Methods. Okay, so we put func. All right, func. Okay, let's see what it's expected to be called. It's called square of sum. Okay, so there are 3 different ones. Let's just run all of those tests. So, okay. Oops, what did I do? Okay, so I have func, and so this first one needs to be named sum of squares. And so when we declare it, we put n, or no, what is by? Oh, they have 2 different names, right? I don't need, yeah, I remember them having 2 different names because they use a lot of keyword arguments, function argument labels, and parameter names. Okay, I'm just going to call it n int and see if that's okay. N int. Okay, so let's do the formula again. And do we have to say return? I don't think we do, right? Here they put return. Let me try it without return. So we know it should be n times n plus 1 divide 2 to the power of 2. I don't know if that's the syntax, but then func square of sums. Oh, there's a hint. Cannot find operator O. Okay, Swift exponentiation operator? Maybe? There isn't an operator, but you use a POW. Okay, let's try a POW. Cannot find POW in scope. Use the POW function. We could declare an infix operator if we like, so that's cool. It says cannot find POW in scope. Let's see. Swift cannot find POW in scope. Import foundation. Let's try that. Is that better? I think so. No exact matches in call to global function POW. Really? Because I have an extra gizmo there. Wait. Cannot convert value of type int to expected argument type decimal. Okay, Swift typecast. You put as. Is that? No. Must be unwrapped to value of type decimal. Cannot convert value of type int to type decimal. Okay, so I think what we do is we just put that. I am messing it up. Let's see, binary operator, operands of type something and something. No, okay, hold on. Int to decimal Swift. I don't know. I clearly haven't used Swift much. All right. Just do a just call decimal on it. Okay. All right. Unexpected non-void. Okay, where do we declare the type? Is it here? Blast. Swift function declaration. Swift seems like a nice programming language. I clearly have not used it. Okay, so it says arrow string. Unexpected. Oh, shoot. Okay, func sum of squares. Wait, is it okay now? Oh, maybe it's okay now. All right, let's do this one. Should be much faster now, I think. So we shall return. Did we end up using pow? No, right? So we want to do n times n plus 1 times 2 times n plus 1 divide 6, right? And then difference of squares return square of sums. That's the smaller one, right? Return sum of squares, n minus square of sums, n. Okay, so now what's this say? Expected it says, I think it's going to say the same thing, but let's just see. I might have done something horrible. It seems to be sticking. I don't like that. Fatal error. Okay. Missing argument label N in call. So do they use that in the test? Oh, no, they don't. They initialize it or something. Okay. They pass it into the constructor. Swift class constructor. You know, when I did the Swift tutorial, which wasn't even that long ago, but I didn't spend enough time with it, I guess, to really learn much of anything. But it said to always prefer structs over classes if you don't have a good reason to use a class instead of a struct. But anyway, so all I have to do, I guess, is put a, like, let's see. So they did this, and then temperature in Celsius becomes that. So then how do we do a getter? Get Swift getter and setter. Sure. Properties. I don't know. Let's see. Computed properties, right? Okay, so var with a get. And that's a computed property, right? So then they get it as center here. Okay. Well, I hoped this wouldn't take long, but it's taking forever. All right. So they're not going to be funcs, they're going to be gets. So it's called var sum of squares. And then we put get. No, we put decimal. And then we put get. Okay, so then here, we'll put var n int. Yeah? It definitely seems like nice syntax. I don't know it, but I'm learning just enough to finish the assignment. Okay, so this one is var like this. We don't need any of that. And then this becomes get. Is it something like that? So what is the complaint? Type annotation missing. So here we said get return point. Not sure I quite get that. Here, let's see what it says now. I was weirded out that it took so long. Like, it stuck here for a long time before. It's like, dang. Yeah, I don't know. Try breaking up the... Really, the compiler is unable to type check this expression in reasonable time? This? Well, that seems messed up. It's not right, though, anyway. It should be calling it a decimal or something. Okay. Class squares has no initializers. Darn. So we do need an initializer? Okay. Fair enough. Fair enough. Init. Okay, so the init takes n int. I don't like how slow the compiler seems to work. Maybe it's faster if you're on a Mac or something. I don't know why that would be. I guess it's sticking on this expression. So I need to fix that, and then hopefully, presumably, it will be faster. Oh, good, that's the last one. Okay, unable to type check this expression in reasonable time. Try breaking up the expression into distinct sub-expressions. Okay. All right, so, I mean, it's not right anyway, so I guess it just makes sense. So I'm gonna say, let's say decimal n times decimal n plus 1 prod 1 times 2 times decimal n plus 1, and then return prod 2 over 6. Is it? All right, so will it compile faster now? Where is it? Okay, good. So missing argument label n in call. So I think for that, I think I kind of remember this. I believe we can just put this. Is it like that? I think so. Hey, I remembered something. I remembered something. My brain is like a sieve these days. Okay, so let's look at the error first. No member square of sum. Okay, let's get rid of that S. Okay, square of sums. What the? Oh, I changed it one place, not the other. All right, so 0 tests passed. Did it run the tests? I hoped this would take a shorter amount of time. Okay, prod 1. Oh, change it to let. Sure, let's do let for both of those. And then in the tests, oh, let's see. It says executed 9 tests with 4 failures. Okay, here we go. Assert equal failed. 225 is not equal to 55. Darn. Okay. Let's not import this either. Let's just say, let sum equal, all right? And then we'll do this. Sometimes. Oh, cannot find decimal in scope? It's probably supposed to be an int anyway. Okay, cannot return expression of type duration? Oh no. Oh no. Okay, let's go to the top one. Cannot be applied to operands of type int and double. Binary operator. Okay, let's get rid of those decimal points. Okay, well, it doesn't show any warnings. It shows executed 9 tests with 4 failures. So that's not good. Yeah, 55 is not equal to 225. So, okay, so the formula is still wrong. So we tried to put n here. I put self n equals n. Sure. Then I put a getter here. And we used this formula, n times n plus 1 over 2. And squared that. So then this is n times n plus 1. And then we multiply that by 2 times n plus 1. Then we do subtraction here. Okay, the subtraction should be okay. Which one did it mess up again? It was test sum of squares, so it was never right. Or was it? So difference of squares passed, and this one passed, and this one passed. Huh. So then which one failed? Difference of squares. No. Square of sum 100. Did difference of squares really pass? That's crazy to me. If difference of squares passed and sum of square, or excuse me, difference of squares passed, but square of sum failed, that to me sounds like there's a problem with the test suite. But let's see. There shouldn't be a problem with the test suite, because I mean tons of people have done this. I think. I guess I don't know that for a fact. All right, anyway, so square of sum 5. Let's do this again. So 4 failures. Square of sum, square of sum. Oh my gosh. Assert equal 225 squares 5 square of sum. Do I still have this? And 225. I don't know. I guess I screwed it up. All right. So it's this one, we think? Okay, so it's let sum equal this, and then we return... Wait a minute. Oh my gosh, I have them backwards, don't I? Yeah. I think I made that same mistake in R. Craziness. Two failures now? 170 not equal to minus 170. Okay, so now I have to reverse the difference. All right, well, that one took way longer than it should have, I think. Okay, so let's review what we actually ended up doing. So, very little, actually. Um, so we have a class, it has a constructor, so that's good, I guess. And then we have 3 getters, and I mean, this is good. I feel like if I go back and review these VODs after some time has passed, I think it'll reinforce some things, and I'll actually learn some things about programming language concepts and syntax and whatever. Let's go ahead and submit. It's really crazy that I spent so long on this one of all problems, but I'm going to move on to the next. Is it 8? I'm still going to keep going for a couple more hours. So hopefully, I maybe try and pick up the pace, maybe. So it says passed, so I'm going to mark as complete. Confirm. Return to the exercise. All right, so let's close all these, and we are going to move on. Okay, so exercism. All right, so we're done. We're going to move on to Pangram, and we're going to do it in Julia. So I previously did what in Julia? Roman numerals? I think I had a pretty good time with that. I feel like I was moving faster at that point. Maybe they were just easier problems. I don't know. But let's try this. Okay, so let's go to Julia. And now we have Pangram. Let's check it out. Okay, so let's look at our README on this one. Okay, so the problem is called Pangram. You work for a company that sells fonts. Okay, sure. They'd like to show a different sentence. Oh, yeah, okay, so we have to show all the letters. Did I remember that that's what a pangram was? Off the top of my head, honestly, I didn't remember that that was what a pangram was. Okay, so sure, we have to check to see if they have every letter. Great. And here's an example. So we have all 26 letters of our alphabet. In one sentence. Okay. Um, I mean, it sounds simple enough. So if I were to do this in JavaScript, I would say this, right? And then I would say, um, what is it? Is it length? Is it size? I don't remember. Okay, so A equals new set. A, B, C, D, E, F, G, H, I, J, K, L. So it is delete. And then it's not length, right? It's size. Okay, so let's do it again now. So pangram, or oh, actually, we have to lower though. Okay, so pangram should be false. Okay. If we just leave one off, should be false. Okay. Uh-oh. Did I miss some? So it didn't work. So let's say all equals new set. Let's make that const. Okay, so we've got this set of 26. Then S equals ABC. Okay, so then let's do S2 locale lowercase for each C. Okay, so now in here we removed the ABC. Okay. So now if S equals ABC, and we do this again, so what did I do wrong here? Return S size equals 0. Okay. All equals new set A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. I probably just, hold on. The Z. No, how did I screw it up? Oh, I put an S there. Why is it an S? Okay, that's more like it. So now we should be able to do the quick brown fox jumps over the lazy dog. And it says true, but if we take the S out, then it's false. Okay, so that's cool. So that's kind of what I want to do in Julia. Uh, I mean, yeah. Yeah, that's pretty much it. So return all size equals 0. Okay, so Julia set. Nope, nope, nope. That's something completely different. Julia, actually, I'm a little curious now. It looks kind of cool, right? Like, whoa. I don't think I've ever heard of that. That's pretty neat. But anyway, yeah, that's not what I'm looking for. Julia, programming language set. Okay, collections and data structures. Amazing. Let's take a look. This, wow, this seems cool. Like, what the heck? What? All right. So, collections and data structures, set-like collections. Okay. So, set base dot set. Sets are mutable. In Julia, do we have a REPL? We should, right? So if we just go in here and we put Julia, can we just get started? Oh my gosh. It even looks cool. All right, very nice. Okay, so now let's try out whatever it was showing us to do. So we want to say S equals set. Sure. Okay, so let's say ABC equals uh-oh. Okay, so we have to use double quotes, right? Now are we okay? Okay. So now, can we spread Julia spread operator? Maybe it's a splat? I don't know. Let's see. 3 dots. Yeah, that's a splat. So that's a little bit different. Julia programming language string to list, string to array, split. Okay, let's try. Split ABC. One element vector. Cool. All right, so now if can we pass this? 26 element vector. All right, seems like a good start. So now, if we pass the 26 element vector here, are we going to get what we want? It looks like they just passed a string. So let's say set ABC. Set char with 26 elements. Superb. Superb. All right. So then what were the other things that we wanted to do? So we want to set. Okay. So now let's do a for each or something. Yeah, let's do a for each. I bet it's pretty simple. For each. For each item in vector. Let's take a look. Use the map command. Cool. Cool, cool, cool. Wait a minute. Okay, let's try this map command, I guess. So in this one, I'm using for each, and then I have a side effect here, which is kind of what I wanted. So if we don't do that, if we do a map instead, I guess I can just map with a side effect. I mean, this would still work if this were map. I just wouldn't usually do it that way, because... So if we change it like this... Yeah, because we're just doing it for the side effect, right? Okay, let's try it with the map. So we're going to map... And then we're going to put in some kind of a lambda here. So I'm going to say C, and we're going to say, or let's say, S equals set ABC. Okay, and then map C. Do we have like help like in Python? Help. Julia REPL help. Oh, somebody asked the exact question right here. Oh, cool. Amazing. Okay. Is this what I wanted to know about? Oh, is of type set? Mutable containers. So you use a push command to add something to it. All right, cool. And to remove something, we put... It's not empty, is it? I guess we can try that. Okay. So S has these. So if we do empty, and then put the character N, and put S, the function empty exists, but no method is defined for this combination of argument types. Okay. So if we empty S, then we get nothing. So S equals set ABC. Okay. And then set push empty union in. Where do we remove things from it? Maybe we want something different. Okay, let's see. So it's a collection. Yep, this is what we just saw. Empty. Remove all elements. Okay, what if I just want to remove one element? What if I just want to remove one element? Let's see. Abstract bit set dict union in is equal. Push. Makes sense. Pop? Oh, let's try pop. No, that doesn't quite seem right. So they do show that you can pop it, I guess. Let's see. Pop S. So we got the N. And now there's 25 elements left. Okay. So now we can pop, let's try popping the B, which is at the end, I guess. So SB. So we got the B. Oh, okay, so we want to pop. Okay. So S equals set ABC. So there's our set with 26 elements. Then we want to map, all right, C, and we will do pop, and we'll use a side effect, or try to, we'll see if it allows it. And we'll do that, and then we'll just put in, like, A, B, C. Yeah? Okay, so we got that mapped, fine, and now S has 23. Okay, amazing. So that's basically it. Are there any other elements we want? Oh, how about lowercase? Or actually, hold on. So we used split before, right? Okay. Can we do lowercase? Okay. I think that about covers it. Let's Q. How do we quit? Couldn't find quit. Exit. Okay. So let's go into the Julia file. All right, so here we go. So we have this function. So I'm going to say ABC equals, one last time, I feel like I typed it fastest the first time. I don't know. All right, so we're going to say S equals set ABC. Okay. And then we'll say lower input equals lowercase input. Okay. And then what's next? We're going to say map so we're going to pop SC, right? Use the side effect there. And we're going to put in split lower input. And then do we do return? How does it, is it supposed to be with a big R like that? We will return. Oh, it's big R like this here. All right. I didn't get the size though. I guess that was the last element. So let's go back into here. Okay, S equals set ABC. Same mistake as before. Okay. Size S. Is it len? Maybe it's len. Len S. Length S. Length S. Length S equals 0. Okay. So yes, let's exit. Exit. Okay. Return length S equals 0. Let's test. Oh my goodness gracious, what is all that? Error, error, error like mad. Okay, what did we do wrong here? Oh my gosh. That's a lot of output coming out of there. Oh my goodness gracious. Okay, so key 7 not found. Oh, okay. I didn't try that. So, S equals set ABC. Okay. 3 times. Let's just remember, we have to use double quotes for a string in Julia. We can do this, and that's a Unicode, or we can do this, and that's a string. All right. So we want to pop SD. And it says error, key D not found. Okay. So what if we do pop without the bang? What does that do? Okay, so we only use the bang. So is the bang to remind us that we're mutating something? That's kind of nice. Let's see. Mutating in Julia. Yeah, I think the exclamation point is maybe to remind us that we're mutating something. All right, yep. These functions' names are suffixed with bang. That's cool. So, let's see. So I guess we just have to check whether it's in there first, right? So S in, or excuse me, D in S, false. Okay. Julia, programming language, ternary, maybe. Okay. Or do we just want to do and? Boolean operators in Julia. Let's see what we got. Okay, cool. Oh, wait. So this is short-circuiting. Which ones are not short-circuiting? Boolean. Short-circuiting and. Is there and without short-circuiting? They're just reminding us that it's short-circuiting. Okay, cool. So we want to say D in S and pop SD, right? So then it just says false. Okay, so if we try C, then we can pop it. Okay, so let's go back. So we want to say C in S and. Okay, let's try that now. Okay, we got some passes this time, so that's progress, I suppose. So let's see, here we go. So what's our first failure? So we put in the quick brown fox jumps over the lazy dog. Okay, so far so good. Um, all right, so did it just come back saying false when it should have said true? With underscores. Okay, I think they all... Okay, so here's another one. Mixed case and punctuation. So I think they must have all come out false. So I obviously didn't do it right. So here's what we've got. There's not a lot in there. Do I think I know where the mistake is? I'm not sure just yet, but let's go and take a look. So let's go into Julia again. Okay. So I'm just gonna try and copy here. Okay, got that. Got that. Okay, now let's have an input. Let's do this. Input equals. Okay. Now let's do this. Okay. And then let's do this. I'm guessing the problem would probably be there. Okay, so now I have 48. Oh. Okay, so I have a 48 element vector coming out of the map, but we just discard that. We don't save that. Okay, so now let's look at length S. 26. Well, I don't like that. Okay, so let's just look at this part. What comes out of here? Did I copy? "48 element vector." Uh-oh, they're all strings. They need to be chars. Julia, string to char. Not array. Yeah, let's look here. Stack Overflow, the world's greatest website. It's pretty much on par almost with Wikipedia. Wikipedia is the greatest. And Stack Overflow is another great one. All right, so only. Okay, why is it called only? Here, let's see. Only. Return the one and only element. Okay. So, if we do this, I'm going to put only here, and then I'm going to map again. I'll just use a different letter this time, I guess. Okay, and then I'm going to go to the end. Oh, key T not found. Oh. Oh, I needed to delete this. My bad. Okay, so that's what came out, and now S is empty. Amazing. So let's exit, and let's go here. Okay, so I'm gonna say string vector input equals split lower input like this, and then I'm gonna put char vector input equals map only C, right? And then put string vector input, okay? And then here we are gonna do char vector. I think that should be better. Let's take a look. Pass 13. Okay, let's see what the failure is. It's a little better. It's a little better. It says collection is empty, must contain exactly one element. Oh, that's messed up. And which one was it? Empty string passed in? Empty sentence error. Okay, so let's just check for that as a special case, I think. If input equals this. I don't know the syntax of an if statement in Julia. Return false. Let me just try it like that. Nope. Julia if statement. Control flow. Conditional evaluation. Okay, I put a colon like Python. That's crazy. So if... Oh, there has to be an end. Ah, you know, if I keep doing these enough, I might start to remember some things. All right, so now they all passed. Let's submit. All right, that one wasn't too bad. Compared to what has gone before. All right, so that passed. Let's mark as complete. Okay. Love it, love it. All right, let's close all these. Let's see what's up next. So Julia is nice. Julia is easy. I say that. I mean, I haven't ever really used Julia, but it seems easy. Okay, so this next one is Elixir again. Okay, so this is going to be the third Elixir. Um, let me think here. Is this going to be tougher in Elixir? I don't think I'm going to do it any faster than I did it in Julia. Probably a bit slower, but I don't think it'll be too bad. I actually practiced with Elixir some in the past, but it was a while. It was quite a while ago. And then, of course, I've practiced with it this year in the exercism challenge. All right. So let's look in our lib. Pangram. Okay. Oh, nice. Determines if it's a pangram. Returns a boolean. All right. All right. Cool. Cool. Yeah, so let's do it similar to what I did with Julia. We'll try IEX. Okay, interactive elixir, love it. Okay, so let's say ABC equals. Okay. So I have the ABC, that's great. All right, so elixir programming language set. All right, so here is a set on the hex docs. Use map set. Okay, that sounds like a winner. A set is a data structure that can contain unique elements. Okay, map set is the go-to. Sounds like a winner to me, baby. All right. So now, can we do new map set new ABC? Enumerable not implemented for this string of type bitstring. Okay. So let's try string to list. Elixir string to list. Take a quick look. We just use like split or something. Split ABC. Okay. Undefined function split. There is no such import. All right, fair enough, fair enough. Elixir examples GitHub IO. Sure, let's take a peek, I guess. Graphemes. I guess that's okay. Do you think that's what we need to do? Maybe, maybe. Okay, so now if we do this, should we try it like this? Okay. That looks like a winner to me. That looks like a winning start. All right, so now we have everything in the set. So now, can we remove things from the set? The one thing, the biggest thing that I remember about Elixir is that everything is like immutable, right? So if we want to take something out of there, then presumably we're going to end up with a copy of everything in the set except for the thing that we don't want, I'm guessing. So here's our summary. So delete. Let's take a look. All right, so now we'll try deleting a letter from there. Amazing, it's gone. Okay, so that's actually pretty great. So now, you think it's like len or something? Length, not a list. Size. Let's see. delete different size. Oh, we got to do map set dot size, right? Okay. That makes sense. So 25. This seems cool. This seems fine. So all right, so now we've got to go through all of the letters in the sentence that comes in and take them all out. And in fact, I think the best way is going to be, so we have ABC, converting that to graphemes, right? So we do like that. But then the other thing is going to be like the input. So we'll say input equals let's start with some input, and then we'll do okay, so I have an ABC set like this, and then I want an input set equals input graphemes. Okay. And then we're going to do difference. So ABC set map set difference input set. And then everything is gone. Right? So now we'll try it with a small input. Okay, so that's all that's there. ABC set should still be fine, right? We didn't make any change there. Okay, so now let's do this again. All right, so now we see that just ABC were taken out. So I think it's probably, I think that's a lot of it. Let's go back to our file here. Okay. So I'm going to say ABC equals okay. And then I'm going to say ABC set equals ABC map set new. I left out the graphemes. String graphemes. Okay. Input set equals sentence graphemes. Okay. And then we'll just say ABC set map set difference input set map set size and I'll just say this is missing and then missing equals 0. Let's try running the test, baby. It says 14. Okay, so we excluded 13, so let's edit the test file. Tag pending. All right, cool. 3 failures. Let's see. So we had expected truthy got false when we put in 5 quacking zephyrs jolt my wax bed. Okay, so that should be enough letters, but we messed it up. So So we were good with these ones, but then what about this one? The quick... Oh, I never lowercased it, did I? Nope, I didn't. All right. Elixir string lower. I think it's just string dot lower. Let's see. No, it's... Oh, no, I was completely wrong. It was downcase. What can I say? I did not remember. All right. So... Is that better? It might be better for... Oh, yeah. It is better. Okay, let's submit. Okay, let's take a look. I'm gonna have to take a quick 5-minute break, probably. Oh, there's a suggestion. It says... Snake case. Okay, that's a good suggestion. All right, so... Hey, let's submit again. Very, very good. Okay, let's check it out. All right, so this one passed. And yeah, let's move on. I'm gonna have to take a 5-minute break. All right. So yeah, that wasn't too bad. It was actually not as bad as I kind of imagined it might have been. So, where's my... Did I even look at what the next one is? We did Julia. Oh, the next one is Go. That shouldn't be too bad at all. So, let's copy this over. Yeah, this is a simple one. All right, I gotta come back in like 5 minutes. I didn't, oh my gosh, I didn't think to put up my, whatever, my BRB logo. Well, I'm back now. Okay. All right, so let's do this in Go. All right. So I have practiced more with Go than some of these others, but gotta be real, like, I'm gonna have to look up probably just as much syntax as with most of these other languages. Probably. Let's look at our Go file. Okay, panic. Well, let's not panic. Here, I don't know if people, um, so we'll return at the end. And I mean, that right there should just return false all the time, right? Let's look at our test file. Cases, let's look at our cases file. I guess that's the one. Cases, K. All right. Let's see what the test says. Okay, so it just shows the different fails. All right. Okay, so we want to make a slice of letters, right? Or do we? Does it even matter? We're gonna go 4. Is that how we do it? Like I say, I'm gonna have to look up some syntax and stuff, but I think that's okay. So we're gonna go over all of these, but first, let's say ABC is, one last time, baby. I've come to weirdly sort of hate typing that out. I don't know. All right, I probably should have just copy pasted. Avatsal says, yo, hey Avatsal, how is it going, man? All right, so we want to make a set. Oh yeah, in Go we don't have a set like construct per se. Instead we make just a map and they just map to like empty structs or whatever. It's fine. Okay, so let's make map, and then is it like this? So it's map of rune to struct. I don't remember. Make let's see, go make map. Where is the tour? I just want to look at it in the tour. There's an even easier way, says Noir Pie. Yeah, if you want to say, I am all ears. Building a new list of all chars unique and count if it's 26. If so, it's a pangram. If not, it's not. Well, sort of, but they include things like if we used like a regex to just match A through Z, then that would probably be the way, right? In fact, yeah, let's do it that way. Because, let's see, building a new list of all chars unique. Yeah, it can't be all chars. But yeah, you're right. That is a good, easier way. So in the example, they have like spaces or underscores. So we just have to use a regex to match A through Z and then do exactly what you said. Yeah, all chars of the input, but not underscores or spaces or numbers. Yeah. No, we don't need. We don't need what? We don't need a regex. Just pop out the letters. Dedupe and count the length. Pop out the letters without using a regex. Like, what is your thought? I think you're right. Like, yeah, we just need to remove like non-letter chars. That's all I'm saying. Okay, let me look up the Go regex. Let's just do it. Regex. Here we go. So we are going to go into our file. We are going to totally import regex. There we go, regex. And then we are going to do a sub. Where's sub? Sub match. I think I'm in the wrong place. Where's regex? Go regex substitute. No, what are all these results? Just get it. Yeah, right here. Match, compile, copy, find all, longest, sub. Oh, replace all. Replace, not substitute. Okay, that's fine. All right, so we will replace all. So this is a method on a regex. Okay. So we'll do must compile. All right, so I guess we can get rid of this. Hooray! Okay, so re equals regex must compile and shoot. What is the remove all non-letter chars, then deduplicate the input string. Unicode is letter method. Let's see. Let's think this through for a sec. Yeah, I do want to do it your way for sure. For some reason I don't remember what is it that we what's the string? Is it like these? I think it's like these. Okay, so we just want A through Z, and we want anything that is not A through Z. Okay, and then we will do replace all. Okay, so we'll say letters only is input, no, regex replace all. Oh, no, it's a method on re. Re replace, there we go. And that will be on input. Oh, we put replace all str, or no, replace all string. Okay. All right, so letters only. All right, so now we dedupe. Deduped equals, And then okay, let's see. What did I miss here? Unicode is letter. All right, fine. A through Z, A through Z. If we want to try regex. Y, okay, you're doing it the other way around. All right. Let's say, how do we make this like case insensitive? Flags. The way I remember it, I think we put the flag at the beginning or something in this regex. Insensitive? No, there's something about the syntax somewhere. Where is it? Right here. Flags. Okay, so set flags during RE. Okay, so here we are gonna put RE to set the flags, I believe. And I for case insensitive. Okay, cool. And then, okay, so we got rid of the letters. Okay, so now we want to dedupe. I guess we could dedupe before or after, right? But whatever. So let's dedupe. Yeah, but I guess it'll just be a slice, right? And I have to remind myself, go tour, we make the slice. I just haven't practiced much. All right. What did that do? Okay, here we go. Okay, slice. Why do I want to do that? Let's not even do that. Let's just say for, okay, so here we'll do letters only, and then we'll do a set, and that will be the map that we wanted. And again, I was going to look up the syntax of the map. Maps. Okay, so map of whatever to whatever. Make map of room to struct. Okay, so then we'll say if s, okay, then how do we, oh yeah. So we say okay is s sub c if now, so I guess I'm trying to dedupe basically, right? So if not okay, so deduped length equals 0. So if not okay, deduped length plus equals 1. I think that's what I'm thinking. And then regardless, we will say s sub c. And then how do we set something on the map? Do we just say like that? S sub c equals struct. And then here at the end, we say is pangram equals deduped length equals 26. And then that's it. Okay, and then what's this? There. Okay, I'm going to try running it and see what it says. All right, we've got some why struct just bool? We want to know while we iterate over the letters if we already had this letter. If yes, set letter in map to true. So using the empty struct is just like a placeholder because we don't actually need to map to anything. We just want to know if it's been seen already. Anyway, so I mean, clearly it didn't work yet. Oh, interesting. I got a true where it wanted a false. That's a little surprising. A quick movement of the enemy will jeopardize 5 gunboats. Was that one supposed to be... So that's missing the letter X, but it said, oh, it said true. Interesting. So I didn't do it right. So if not okay, deduped length plus equals 1. So the idea is that we've seen it, we haven't seen it already, and so we plus the length. And then, interesting, but apparently I plussed it too many times. Okay, what do we want to know here? So if not okay, can we do that? I want it as a letter. Let's see. Print F. Go. Print F room. Oh, just, yeah, just do string. Okay. So we got... So yeah, I can see that it didn't work because here's the T, and then here's the T again. So if not okay, so that didn't work at all. Can I print that out? I don't know what it's gonna show. Oh, okay. It shows numbers and everything, so that's cool, I guess. So we put in the A, got the 97. Go map okay. So if okay, then it contains the key. Interesting, interesting. I'm gonna make this a string just so it's easier to read. Now C. C equals string R. Okay, A, B, C, D, E, F, G, H, I, J, K. Oh, of course. Go string lower case. Yeah, I just should have done that in the first place. 2 lower. Okay. Well, I didn't see the problem at first. Okay, so we'll say lowered equals strings 2 lower input. Input lowered. All right. So that looks better behaved, at least, I guess. All right, so only lowercase, missing the letter X. Oh no, I'm still seeing the same problems. Five quacking, so, okay, got false, false, false. I'm curious, especially about these ones where it's true and wants false. Missing the letter H. 5 boxing wizards jump quickly at it and got true. I've got a 1 in there. I should not have a 1 in there. At least I wasn't supposed to. Looks like it, whatever I tried to do didn't work. Letters only. Looks like there are things other than letters in letters only. Yeah, it looks like there's a space there. Hold on. Okay. Yeah, it's... Didn't work, didn't work, didn't work. Okay, so we were supposed to replace all string. So we were supposed to replace everything but a letter. It didn't work. I don't need to do that. So it was supposed to be not A through Z plus... And then we were supposed to replace... Well, let's see if it's any different now. Oh, it is. Okay, so the flag didn't work. Okay, before I move on, why was my flag messed up? So I was supposed to put flags, RE, non-capturing. It was supposed to be set. Set flags during RE, non-capturing. Well? Oh, wait a minute. Was this supposed to be the whole RE? Okay, let me try it again. Alright, so... Oh, and did it pass? Okay, everything passed. But I do want to figure out what I did wrong here. So, I want this I, but it looks like this is supposed to be the RE, and I just didn't understand that at all. Oh my gosh, okay. Alright. So that was the last pangram. Oh. That was the last pangram. So I'm going to move on. Okay. So let's see. If char greater than equal A and char less than equal Z, with that simple line, we don't need any regex. Well, yeah, but I love regex, and I want to know how to do them in each language. I'm learning. So, but yeah, sure. Let's just do that real quick. So we don't want this. We don't want this. We don't want this. We don't want this. Don't want this. And then here we say, and what you said, right? Um, so R greater equal to A and R less than equal Z. Whoops. Meant to test. Oh, I still have RE in there. So yeah, we don't need this. And then this becomes lowered. Okay, so that's good. Awesome possum. Yeah, love it. So we do it without regex because we just check this guy. If you put the if above, you don't even need to check if it's in the map, if it's not an alphabetical character. Okay, let's take a look. All right, so for this all, so we'll just say if R greater equal A here and R less than equal Z here. All right, and then we'll close that out. And then we don't need to check again, of course. There it is. Go format. And then, okay, so we do this. So we don't do anything if it's not a letter. If it is a letter, we'll make it a string. And actually, the only reason I made it a string was to make it easier to read when I print it out. So if I'm not printing out anymore, I guess that's not really necessary. So let's make that a rune again. I don't know, like, I probably would leave it a string just in case I wanted to print it out again sometime. But for the sake of it's just a puzzle, let's just do it with it just being a rune. Okay, so that's okay. Any other refactorings? So we return like this. So I'm gonna change to just return this and get rid of, well, actually, I'm just gonna leave it. Okay, so that's cool. This is the only place we return, right? So that's good. Okay, now let's do the refactor you were saying earlier, is we could just make this a bool. Again, like, I got used to using the empty struct as a placeholder, because, like, we can make that a true, and that's fine. I think it's fine either way. Because it's never going to be false, we're just using it whatever placeholder. It could be just an int or anything. So we do want a lower case, of course. We do want the deduped length initialized to 0. It could also be like this. Let's see if that's fine. Okay, that's good. Yeah, that's a pretty good refactoring, I think. I mean, I would change some of those things back, probably, because, like, making it a string just made it a lot easier to read the map. All right, let's see. And I think a map with a bool would be better, because we are literally just storing a 0 or a 1, and a bool has less overhead. Well, the empty struct has nothing in it, so I think that's why, like, I don't remember who told me to do it that way, but like the empty struct just doesn't have anything in it, so it's minimal overhead basically. But I don't really think it matters either way. Let's just look it up real quick. Golang empty struct. Because, like, yeah, because there's literally nothing in there. So this person says with 109 votes, it's the smallest building block in Go. Size is literally 0 bytes. Love it. If it has 0 size, you create a slice of thousands empty structures, and this slice will be very tiny, right, because there's no bytes in it. All pointers to it always point to the same special place in memory. Very useful in channels. When you don't need to pass any information. Yep. Pass an empty struct because it only increments a counter in the channel, doesn't assign memory, copy elements, and so on. Go has no set object, can be easily realized as map key type struct. So yeah, this is kind of, I haven't seen this answer before. I wish they linked to where in the docs they got this from. I think, let's see, Golang language spec. It might have been in here. Struct. So struct types. Okay, yeah, so empty struct. And is there something else about it? I don't know if it was in here that I thought it suggested using empty struct for things like that. But I have seen it suggested for sure. Empty struct? It's only mentioned here. But yeah, I think this guy is right. Like, its size is 0. You can use it like this. And so I think it's fine either way. It's optimized, it has nothing, but it could have an overhead. But yeah, in such a simple script, it's irrelevant. Yeah, like, just the fact that we're not ever gonna use this value. Yeah. So just a pointer to some... It's essentially, it's not like a nil. Honestly, can you do nil there? No, you can't. Nil is not a type. You could even do, you could even make this any, right? And then just put that in there. That's also possible. Anyway, I'm going to move on from the pangrams because I didn't want to spend too much time on the pan. I think that one, honestly, is probably the easiest one in here yet. Most all of them have been pretty easy, but that one was quite easy. All right. But we did it a couple different ways. Oh, I still have to submit. Or mark as complete, rather. All right. I think what made it so easy is it was just simple, easy, nice programming languages. Julia was very nice. Elixir very nice. Go very nice. All right, let's do C++, all your base. Here we go, baby. Okay, let's see what we're looking at. Hopefully I'll finish at least the C++. I don't know. I don't know what I'm expecting here. Okay. Here is what... Oh, okay. A base conversion. Mathematics, okay. Every answer is wrong. The student answers are correct, but they're in binary. Wow. Each week, the students use a different base? Sure. Okay, convert a sequence of digits in one base representing a number into a sequence of digits in another base representing the same number. Try to implement the conversion yourself. Do not use something else to perform the conversion for you. All right. So let's take a look here. I'm gonna stop pretty soon. We have Erlang. I haven't done an Erlang yet, and we have Groovy. So let's take a quick look. So if we're trying to convert a base and we're not using any language functions, right? So like if we're in here, then if I have some number, I can go string, and then I can go number no, what is it? To number dot parse, that's what it is. Parse int. And we can make it whatever other base. So we could even do like 7 or whatever. All right, so if we don't want to do that, we want to say base conv equals, and we're going to pass in an n and a to and a from, basically, I guess, something like that. All right, so then we're gonna, I guess, just use a while loop, honestly, probably. So while n greater than 0, did they say if it's a natural number? Or could it be like decimals, or what could it be? Let's take a look at the tests. So we're gonna test 1. Are any of them like negative or float or anything like that? It looks like they're all non-negative integers. Probably. I think so. All right, so let's just say it's all non-negative integers. So I would go while n greater than 0. And then I would go, let's see. Okay, so the first, oh, interesting. Let's see, do I know this? They're passed in as a number. Base 10, base 2. Okay, they're passing it in as digits, not as just an int or anything like that. Okay, I didn't realize or understand that at first. Okay, so if it's all just digits, then this n is actually going to be a, right? I guess. And so then I would go for I equals a dot length minus 1. I greater than equals 0. I minus minus. So we start at the end, and then we just go, and then we have to output digits as well. So I would say digits equals this, maybe. And then are we gonna push them on there one at a time? I think I'll push them on and just reverse at the end here real quick. So we're gonna go no, you know what? I should start with 0 probably. Less than a length plus plus. And then digit equals a sub a length minus 1 minus I. And then value equals digit times I to the power of from. And so that would get the value. All right, so far so good. And then digits push and then we have to get the right amount of actual digits. So we would go Man, honestly, it would probably be better or easier to get the whole value first and then do it in 2 steps. So whole value equals 0, and then whole value plus equals value. Okay, so then end there, and then do another one, say while whole value greater than 0, and then go digits push whole value mod 2, and then whole value equals math floor whole value over 2. And then return digits reverse. Honestly, I don't think that's quite right, but let's see. So we did 0, 0, 0, and we expected to get back nothing. So let's take a look. Okay, got back nothing. If we did just 1, 0, we expected nothing back. Okay. If we put nothing in at all, we expected nothing back. Okay. Okay, here's one. 346.60. Oh, I got nothing back in that case. That's not good. Okay, so let's do this again. So let's say console log whole value. Did we get something there? Uh-oh, not a number. Whole value equals 0. Whole value plus equals value, where the digit was what? Oh, I didn't put in to and from. Let's put in to and from. So it should be 97 and hold on, single bit 1 to decimal, 2 to 10. Okay, so this was 97 to 73. Oh my goodness gracious, what the heck am I putting out here? Out digits equals, so expected was 610 to 45. So that's not anywhere sensibly close. 97 and 73. Too late in the game, but could have done with array. Didn't see your solution. Norsimo5, thanks for chatting. Do you mean the which one do you mean could have done with array? Are you talking about the pangram or are you talking about the base conversion? Old comment, yeah. Yeah, I'm gonna try to get used to reading them faster. Ha 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 ha. Yeah, we can look at the pangram. I don't know if I'm gonna get much further tonight. I still have time. So for the pangram, we looked at doing it a couple different ways. So which one did I do first? Julia? So for Julia, pretty easy. So I first checked for empty string as a special case. Then I set all my letters. And then I made this into a set because then we can pop later. So then we lowercase the input and then split that to a vector. And then we made them into chars because when we split it, they came out as strings. And I wanted them as chars because that's what ended up in the set. I don't know. And then, yeah, so then if it was in there, then we popped it and that was it. And then similarly in Elixir, I think the Elixir one seemed a little nicer in some ways. Let's see. So iteration 2. So yeah, this one looks a little nicer, I think. So we did the ABCs, Then we set it to a map set of the graphemes from there. Then we downcase the, I mean, I'm pretty much doing the same thing, but I think it looks nicer this way. We downcase the input sentence. The sentence is what was input, and do that. And then here's what I did is I used the map set difference. Honestly, that's what would have made it nicer in Julia, is if I had used a difference. I'm pretty sure Julia has a set difference. I just didn't think of it. And so that was it. But then in Go, we did it a different way. I was going to start to do it the same way, but they suggested doing it a different way, which is instead of using a set, well, actually, we do still use a set, but instead of checking like whether anything, or like instead of making a set of everything that's in there, well, honestly, it ended up being kind of similar, but we basically just counted whatever letter was not in the set. Yeah, it did end up pretty similar. So I think we were thinking of doing it like without a set. It's just using a set is an easy way to dedupe it, but if we deduped it another way, then we would have done it without using a set. Jumped in when we finished the Go version, yeah. So that was cool. So then for this base conversion, I don't think I'm anywhere close. Let's see. Wait, let me try one of the simpler ones. What's this first one? So single bit 1 to decimal should come 1, 1. Okay. So we want just a 1 and a 2 and a 10. Okay. 1. Oh, you know what? I have those reversed. This should be, at least I think I do. Oh gosh. Okay, so just a 1. We're going to single bit 1 to decimal. So the 10 is 2. 10, 2. Uh-oh. That didn't work at all. Oh, no. Okay, so I think I've made some silly mistake. Obviously. Okay, so I got the 1. So far, so good. But then this came out as a Z. Oh, because this is the I. So should I add 1 to the I there? Yes, I think so. So that was an off by 1. Maybe that's more like it. Okay, so now I got the 1 back. Okay, so then the next one is 1, 0, 1, which should turn to 5. Okay, makes sense. 1, 0, 1. Uh-oh, it came back as 10. That's messed up. Okay, so I got the 1. Digit times I plus 1 to the power of from. And the from is 2. Okay, so we added the 1, then nothing, and then 9? That doesn't seem right. Value, okay, so console log value. So this was 1. 9. I don't know. Let me see here. Okay, so a digit. Okay. Digit equals 1. From equals 2. I equals, what was it supposed to be at that point? 2, I think. Okay. Digit times I plus 1 to the power of from 9. Okay, I'm missing a parenthesis, and I didn't see it till just now. Okay. Nope, it still says 9. Digit equals 1. From equals 2. I equals 2. Digit times I plus 1 to the from. Oh. Oh my gosh. So we raise to the power of this. No. Digit times from. Okay. Ah. Crazy, crazy, crazy. Okay, so 8. Okay. So ah. No. So terrible. Okay, so from goes here, of course. Not here. Oh my gosh. Oh my gosh. So base conv, which is the one I want next. This one. No. Okay, so I've got 8 here. That's good. Is it though? No, it's not. It's not good at all. So the +1 was a mistake all along. It was just me trying to fix something without knowing what I was doing. Okay. Okay, so there's the 5. Then if we go the other direction, so we just put in a 5 here and swap these. So then we get the 101 back. All right, so now if it's 1, 0, something, something, 1, 0, etc., etc. Base conv, paste, 210. Let's do 10, 2, 4, 2. Okay, sure. Then we do the other direction. Make this a 4, 2, 210, 101, 010. Okay. And okay, 1120. This is from 3 to 16. Okay. 1120. Why did I reverse those? That's silly. Let me redo it with them reversed the other way. It should be from, then to, obviously. Okay, so from 3 to 16 to 10. Okay, that's fine. All right, and then let's see, 210 reverse. Okay. 210, 16, 3, and 120. Okay, so then if we do 346.60, and the numbers are from 97 to 73, ha! I got 610.45. Okay, that's good. And then let's check the empty again. So empty, and we're going 2 to 10. Okay, that's fine. Let's get rid of that console log since we don't need it. Okay. And then... Okay. Then if it's just a 0... And which way are we going? And then if it's 3 zeros... And then if it's 0, 6, 0... And this is from 7 to 10. 4, 2, okay. And first base is 1. Oh, invalid argument. Okay. So, if from equals 1 or 2 equals 1, throw invalid arguments. Okay. Okay, good. And then first base is 0. Okay. Less than equal to 1. Okay, invalid argument. Invalid positive digit. Okay. So for these ones, we're going to say... So we got the digit. We'll say if digit greater than or equal to from row, and it just says invalid argument. Okay, so we have 1, 2, 1. Oops. Copy. Two, 10. Invalid argument. Okay. Oh. And then what was this? Okay. 0, invalid positive. Second base is 1, second base is 0. Okay, those should be fine. 1. And 0. Okay. Time is it? Okay, good. All right, so this, I guess, works. I'm tempted to kind of just submit this JavaScript one. I think I'm actually going to this time. I don't know. Yeah, I think I'm going to submit the JavaScript one. So here we go. Let's copy here. Downloading. Okay. So npm I. npm I is so slow. When I was doing JavaScript all the time and not other things, I never minded, but practicing a lot of these languages, a lot of them are so much faster. Like just doing things like Go, it tends to be way faster from what I've generally experienced. Right? Like this is such a tiny little JavaScript project and the npm I still takes that long. It's crazy. All right, so let's go in here. And this is a skeleton file. So I'm just going to paste, oh wait, I'm going to paste this. And what does this say? So I'm going to use it here. But let me see how they actually call the convert. All right, so they pass in. Oh, yeah. Export const convert. Yeah, let's just make this convert. Okay, so digits const. Whole value should be let I const skipped 20. Oh my goodness gracious. All right. "13 failed." Oh, expected message, wrong input base. Oh, interesting. Okay. Wrong input base. So if from is less than equal 1, throw wrong input base. If 2 is less than equal 1, throw wrong output base. And then here, well, actually, what's it say? Expected message, wrong input base, received value, wrong input base. Wait a minute. Do I have to new it up? Uh-oh. Okay, input has wrong format. New error. Input has wrong format. All right, expected. Oh, did not throw. Oh, it was a negative. Goodness gracious. Okay. Or digit less than 0. Okay. Leading zeros. If a 0 is 0, throw new error. Input has wrong format. Okay. Let's see. Okay. Empty list. Oh, so for empty list, we were supposed to say input has wrong format. Oops, not that. Okay, and last one, it says, what is this? Throw new, wait a minute. Converter single 0. Oh, if it's a single 0, then that's okay. So it would be or a length greater than 1 and. Is that right? No, that's not right. Oh no! Expected 3, received 1. What is this? Converter single 0. Oh, I didn't put anything in. Okay. So here, if digits length equals 0, return 0. Okay, let's submit. All right, let's see if that's accepted. What time is it? Ah, I think I'm gonna stop for the night. All right, so I'm gonna mark that as complete. Let's review real quick what we've got. So export const convert. If from is less than equal 1, wrong input base, okay, wrong output base. Input has wrong format, understandable. We'll put the digits. I do want to refactor that a little bit more. Since I've got 4 minutes before or 5 minutes before I want to stop. Oops. So I don't want to declare digits that early. I want to declare digits probably right here. Then is this the way I want to do it with the I, or do I want to consider something else? Yeah, I think I'm happy with doing it that way, probably. This line is too long, I think. I'm just going to move that down. Okay. Whole value plus equals value here. Honestly, I will probably do it. Okay. This line's pretty long too. It's not a skeleton anymore, so it can get rid of that. Okay, looks a little nicer, I guess. I'm gonna put some blank lines in here, here, and here. Okay. And then yeah, I think that's okay. I almost want to change, like, this throw error, I kind of want to move up by the other ones. So if a dot, what is it? Is it sum? Is that what it is? I don't... Okay, if sum yeah, okay, so all the errors kind of by each other. I'm just gonna look a little more similar. Okay, cool. I'm gonna move this up as well. but it's gonna be different. It's gonna be if A equals. Wait a minute. Wait a minute. Can we do that? There we go. Okay, so all those ifs at the top, I don't know if that's any better. I'm just messing around. Um, I kind of like it better, sure. Okay, so then let whole value equal 0. Let's say, yeah, cool. Oh, what about this reversed? Is this making sense? Yeah, I think so. Okay. Let's take a look. Okay, so if from less than equal 1, wrong input base, to less than equal 1, wrong output base, if a length is 0 or a length is greater than 1 and we have a leading 0, then input has wrong format. If there is some d that is either greater than or equal to from or negative, input has wrong format. In that case, we don't do any more processing. Special case, I guess. All right, I am going to quit for the night. So long, everyone, and have a good one.